All right, so welcome to OnScan webinars. Today we will keep talking about Solid Edge 2020. So for today, for yesterday we already covered the basic part design process. We walked through how to generate a part from sketch to the full part, how you adjust the dimensions, how you make change freely to the part. I think you guys already have a basic idea of what the advantage of synchronous technology is. And for today, we're gonna focus on some of the important functions and give you an idea on how those functions work. Okay. So let's get it started. The first thing I want to talk about is actually something we missed from yesterday, which is the material of the part. The part material is important if you want to do simulations or generative design, because for those processes you have to have the physical properties of the object. So you have to decide what material the part is made of. Okay, so to define the material, here on the left list, double click the material. All right, Solid Edge already has a pre-installed material library. Contains several different materials, and of course you can create a new library, or you can actually put in your own materials. So, and you can see that for each material they have densities, other properties like specific heat, thermal conductivity, or other thermal properties, which can be really useful for thermal or cell simulation, things like that. And also texture will be applied to the surface of the part so that you can have different looks for it. All right. So this is for the material.
Next, we will focus on all the details about the sketch functions. So first, for the sketch, the first important thing is the reference plane. You put the sketch down. Okay, we already covered two ways to to settle down the reference plane. One is to use the base reference planes, the XY, YZ, XZ planes, and the other one is from any plane surface on the model. There are also other ways to make planes at places that there's no plane available at all. So, for example, here at the plane functions, we can find first is coincident planes, of course. Then there are three ways to make more planes. First is normal to a curve, like you can see on the screen. You can make a plane normal to a circle curve or other free curves. Or you can do by 3-point, so just like this, pick 3-point to generate a plane. Then we have tangent planes. You can make the plane tangent to a cylinder surface, sphere surface, or so on. Okay, so these are the way that we can make planes. Then after that, let's talk about some of the drawing functions. We only covered some of the simple sketch functions in the last demo. There's actually more you can use. So first, except the rectangle by center, you can do rectangle by 2-point, like this, or you can do 3-point. And also, you're able to make polygons by center. So for example, I can make a hexagon. Or if you want, you can change the size to any number you want. Make sure it's not less than 3, all right? Then of course, for circle, you can do circle by 3 point, like this. 1, 2, 3, okay? Then the other way is to do a tangent circle. So for example, I can make a circle that's tangent to this line, okay, like this. And also, if you want ellipse, you can do here. Then there's also one more important function is called intense zoom, as you can see in the line function. All right, I'll show you how it works. So this one will appear when you start your line from a curve, for example, from this circle. So click on it. You will see that there is a small sphere popped up at one end of your lines, and it's divided into 4 zones called intense zoom. These two that's along the curves are zones that if you move your cursor to it, then out, it will tell the software that you actually want the curve to be perpendicular to the surface. So like this. So no matter how you move your cursor, if it's out from these 2 zones, then it will always be tangent, not perpendicular, sorry, will be always be tangent to the curve. And these 2 zones, you're telling the software you want to be either perpendicular to the curve or at any other random directions, okay? So this one is pretty useful when you actually want to make a tangent lines. For example, I want to make a tangent line to both of the circle, then I can do like this, move out from one side of the intense zoom, then go snap to the tangent point to this other circle. You will see that when I'm snapped to it, how can I tell it's already tangent to the other one is by looking at your cursor, okay? Next to it, there are 2 signs indicating a current relationship that you have for the sketch. The one on the left means connect. So the end of the line is connect to the circle, okay? Then the other one indicating that the end of the line itself is actually tangent to the circle curve, all right? And you will be able to see this at a lot of different places in different forms. For example, if you see this sign, here it means that highlight feature is actually perpendicular to the line you're drawing. And if you see something like this, it means the end of the line is snapped to the center of the highlighted curve. Okay? Then if you see this sign, it means the line is perfectly horizontal, comparing to the base coordinate system. Then of course we have vertical too. And then this one, it means the line is connected to the middle point of the certain line. Okay? So there are a lot of different signs. And for line function, there's also arrow that you can click on, and you will be able to find the way to create point. And also this function is actually pretty interesting. It's only enabled on Windows 10 version 16.07. you will be able to draw freely, and the software will fit a sketch corresponding to a drawing. For example, if I draw a circle like this, it will try to fit a circle, or you can draw a rectangle like this, and it will read your mind. So for example, I want to draw a horizontal line. It will just fit a horizontal line. Okay. This is kind of useful if you are just trying to draw lines. And for example, when I'm designing something, I can first have the thorough shape out by normal drawing. Then I can add on relationship to it. For example, I'm thinking of making something a rectangle shape. So what I can do is, I know I want a line here, a line here, line here, and something a little bit curved. Then you can actually connect them. Okay. Then you can settle angles or dimensions or other things. And of course, we have all other sketch functions like what we do in other CAD software like trim. So you can trim lines that you don't need, like this. Let me see, yeah. Trim like this, okay. Or you can draw a tangent arc. You can split an element at the point. You can trim elements. You can draw fillets like this. Okay. And of course, we have mirror functions. You can scale or stretch. You can move and rotate. And of course, you can do offset or symmetric offset. So all sorts of functions that you can find, sketch functions that you can find in other software, it's all available in drawings. And don't forget all these drawing relationship that you can settle down. We already covered some of them. Here, this lock means you can lock a certain elements and make sure it will not change. All right, so it won't change either place or shape. And this is the tool that you can use to make your sketch. And once the sketch is down, the purpose for sketching is to generate a certain shape of area for extrude or revolve the area. We call it regions. And in solid edge, like I said before, the difference is that the region can be, the boundary of the region can be two things. First, it could be the drawing that you made as you can find in other software, or it could be the edge of a solid body. Like for example, here we have this region that I have made before. You can see the boundary is, first these two are the lines that I made, but this side of the boundary is actually the edge of the upper surface. Okay, so the region is automatically detected as long as there is a full circle constructed by these two elements. It gives you more freedom. You don't have to necessarily to trim them to make a full enclosed shape. That's not necessary. Okay, and it saves you a lot of times. Next, let's talking about the dimensions. We already showed several ways that we can do the dimensions. First, the dimension can be applied to the drawings, like this. Or you can actually apply dimension onto the model itself, like this, okay? But sometimes, for example, I want to know the distance between the center of this hole and the top surface. You will realize that since the right side of this handle is actually inclined 5 degrees, when you are making the dimensions, it's actually perfectly vertical, so it's not really the number that I want. I want the dimension on this 5-degree incline. So what you can do is you can hold Shift, and you will see that the dimension is changed to the minimum distance. It's not really minimum distance, but actually changed to be along the direction, okay? So Shift is the way to change horizontal or along the axle, okay, like this. And after you lay down the number, you will be able to change it. And here you can see first thing at the this putting number window, you can lock your dimensions so it won't be changed if there's other dimension changing. And also you can set which end to be driven end. So if you choose left or right, only one side will be changed, okay? Like this. Since it's already fixed by the pattern, so the right side cannot be changed at all. Or you can do both, okay? Then here we also have design intent. Like I said, when you modify the dimensions, modify the object, the design intent is the thing that help you to intelligently change a lot of different features, different dimensions, so that some of the relationships that you set will be still remain. Okay, so far for the sketch and dimensions. Next we're going to talk about how to make solids, all these solid functions. Before that, let me just delete all these sketches that I don't really need. Okay, delete them. Okay, this looks clear now. And for solids, first, this thing we haven't talked about is that actually Solid Edge giving you ability to make some of the basic shapes easily. For example, they have boxes, they have cylinders, and they have spheres. To draw a box, you just put down 3 points like this. Okay, this is how you make a box. Or you can do cylinders. Is like this: draw a circle, then pull it, or a perfect sphere, like this. So it gives you some basic, easy way to generate basic features like this. Okay. Then of course you can use extrude, which is the most used functions. When we are extruding, we only talked about 2 things before. So we already talked about the symmetric functions. So if you click on it or hold a tap shift, it will extrude or cutting symmetrically on both sides. Okay, and if you click again, it will do only one side. And also here there's a switch to toggle either add or cut material. or do it automatically. All right. And you also have the ability here to select to include internal loops or exclude internal loops, or only use internal loops. For example, for the upsurface, if you include the internal loops, you see all the holes will be left out. But if you choose exclude, then the holes will be filled. Okay? Yeah, of course, if you choose use only the internal loops, it will only create the hole. Okay? Only extend the hole. All right. Okay, next let's talk about the hole function. So we only mentioned that we only did before is making a normal simple hole. Actually, you can make all sorts of a standard thread hole, or like this tapped threads. You can even add a head clearance, or you can put it in all different tap shape or non-tapped. Okay. So here's you can settle the hole options. Then of course when you are drawing holes, there's different way to put the holes onto different key point. So here in the menu, if you choose all, you can see that there's all sorts of different key points you can attach the hole to. For example, what if I want to put the hole right in the middle of this front surface? The way to do it, first you find you lock it to the surface, then you find the center of one side, drag it in, and you go find the center of the other side. And now you can see there's two dashed lines that tell you that the hole is snapped to both of the center of the two edge. So it's now right in the middle. Okay? And of course, you can also add threads after you made the cylinder like this, show in the video. Then here's some other interesting things we haven't mentioned about rounds. First, if you click on the option in the menu bar, you will find that you can even change the round parameters. One thing is you can change how the corners will be. Default is melted at the corner, but you can actually let the software do a row around the corner, so it will change into this. Okay, or you can ask it to cap sharp edges, like show in the picture. You can see the difference. Okay, so different way to set your rounds. And also we have this blend function, which I think is pretty interesting because it's give you the ability to do all different blends. One interesting one is called variable radius blends. For example, because normal round, it's a universal diameter, but with this blend function, you can actually do a round with different diameter on different ends. So like this, you choose this edge, right click, and then you can select the left side, let's say 5 millimeter on this side. Then we change the middle point, give it 20 millimeter. Then the right side, I put 10 into it. You see, I can actually make a blend with various of radius. Okay, of course, you can choose the two sides to be tangent to the surface, or to do a curvature continuous. Okay? So this is a blend. And of course, we have normal draft functions that you need for casting model, okay? Or just adding a draft. Or you can do sing wall. Like you can see, just choose your open surface and it will turn the full model into a sing wall object. And you can add ribs using a guideline, or you can add a web network, which is useful for plastic design, okay? And also you can add a lip to cut out. And also there's some, you can add vent like this. There are some interesting functions that help you to generate pattern features easily, okay? And of course we have sweep and cutting functions too. And the other thing which I think is kind of unique is that you can actually add another body into this part, which is completely independent to the model. Like this, if I click add a body, I can actually draw another box which is perfectly independent. You will see that the other bodies are actually grayed out. So these two are two independent models. So if I move one of them, it will be different from the other one, okay? It's not, these two are not connected, and you can edit them separately. You can even hide one of these bodies. All right? Okay, then besides these, we also have these face relationships. The purpose that Solid Edge provide all those face relations is because, like I said, synchronized technology giving you the ability to control the model directly through either dimensions or these relationships. This is because the drawing is already detached. So before, in other software, we have drawing relationships that controls the model, but now since we don't, we need to have surface relationships to help giving more control on the model, okay? And this will be very useful when you were drawing the 3D model. And also, the other thing that we haven't talking about is the patterns. We already tried the rectangular pattern, so that you're just putting how many rows and how many columns you want, and you can just draw the pattern. There's also different ways to do it. You can do either circular, so along a circle, or you can do along a curve, which you draw by yourself, or you can pattern by table or field pattern. It's kind of straightforward. You can try by yourself. And of course, you're able to do geometry mirror. You can mirror something with the reference of a plane, okay? The last topic, which I think is really, really important and really useful function in Solid Edge, is the, I call it turning wheel in Solid Edge, that we have used in last section to turn this side 5 degrees left. So it actually can help us do a lot of different move or rotate functions for different feature or feature groups. Okay, here are some examples. Before it, let's first take a look at this wheel thing and giving you some introduction on how it works. So as you can see, this is the base of the wheel where you can click and move it around. This settles down the reference of your movement or your rotation. Okay. Then this 3-axle has a knob on the tip of the arrow, which you can turn and change the direction, and you can snap to different features. Okay. Then this wheel that's used to turn, having a wheel plane. Okay. So if you click Shift, then click on the plane, it will actually flip the plane. So it means you actually have all 6 degrees of freedom to do both rotation, 3-axle rotation and 3-axle movement. Okay, so this is the way you turn the wheel, flip it. All right, hold Shift. All right, so let's see 2 examples of how this wheel can help us. First is this shape. How to make this shape easily. All right, it will be really a lot of works if you want to construct this kind of shape in other CAD software, and I'll show you how easy it is to make it in Solid Edge. All right, so let's get it started. First thing, like I said before, we need a sketch. Okay, so let's do 2-point rectangle. Fix on here, like this. This is for the base of it. All right. Now we can extrude to get the base. Then we want the center part, okay? And it looks like we could use just a line like this. All right. We want the cross point, so just move your to both, and when you see this cross sign, it means it snaps to the cross. And here, same thing. All right. So now we have this triangle region. Click on it and pull it out. If you see it's only pulling on one side, remember to press on Shift to make it symmetric. Okay. So let's do something like this. All right. It's almost down, almost down. So the last thing, we're going to use the wheel to turn it. If you click on the surface, you'll realize that it's only one direction arrow. You might say, where is my wheel? Okay, it's easy to bring it up, but you just click it again on the center, and it will just pop up. And since we want to turn along this bottom axle, we just snap the wheel to the bottom, and click on the wheel. Okay. And let's snap to the middle point. And here we go. Nice and easy. All right. This is one example on how you can move and turn your surfaces with the wheel. Okay. And next, here I can show you how you can move features on a different directions that's already settled. So for example, I have 3 holes here. All right. I want to copy this hole and make another one at the place so that these two holes are parallel to these two. So how can I do it? Here's how. So first I select the hole that I want to copy. All right. And since I want to copy it to the place that from this one to this one, so I'm gonna move my wheel to the center of this reference hole. Okay. Then I want to move it along this direction for a certain distance, right? So what I'm gonna do is I'm gonna rotate my tab here, snap to the center of it, okay? Then I click on the arrow. Remember, we need to copy it. So here in the movement bar, make sure you select Move a Copy. Okay. And here, let's snap to the center of it. And here you go. So it's perfectly at the same distance. If you have doubt, we can see if the distance are the same. So you can see the x distance. All right, delta x is 45, delta y is 15. And what about the other one? Same thing, delta x is 45 and delta y is 15. So it's perfectly identical. This is how you can move your features with a certain reference, okay? Okay, so this is what we have today for Solid Edge webinar. Please try by yourself and see how to use the magic wheel to help you turn and move your features, your surfaces. This will help you a lot for easily modifying the model that you made. Okay? Thank you for watching.